All right, going to wait a minute or two here so that anyone who's getting their computers set up can join us. See, we're up to 7 people so far. So, hopefully this will all go smoothly. Last month it was unfortunately canceled due to a power failure from the storms here. Tonight we're once again racing the storms. Line of storms coming through, but hopefully things will go well and we will be able to get through this uneventfully. Yeah, the audio may have some noise in it. I can move my microphone sender up a little bit. I did have some technical difficulties. Hopefully that's a bit better. I had to bring multiple computers down here to get everything to behave, and cables running across the floor. It's a wireless microphone, so see how things go. So I think I'll go ahead and begin. So I'm going to be talking about solar power digital station. So last time we were talking about the solar power, solar battery portion of this. This time I'm going to be talking about the digital operating portion of it. Did this for 2019 and 2020 field days. Pretty much the same setup, but slightly different. So if you saw the last presentation, you probably will recognize some of these graphs and charts. If you didn't, if you go to my YouTube channel, it is available to watch as this presentation will be afterward at your leisure. So here is what my station looked like for 2020. Since I didn't have multiple operators, I didn't see reason to set up a nice table and everything. I just set it up on a cart, and then I could just roll the cart under a tent or something as needed. But it's pretty much the same things. You know, got the same batteries, same radio. You know, all that same computer up there, wherever it is, wherever it is. So yeah, it's all the same things as before. Block diagram here, so 13.8 volts power, hooks up to the radio, which goes out to an antenna, shot an antenna up over a tree. I actually omitted the coax tuning stubs this year. I'm out here fairly rural, don't have many things to compete. It seemed like I didn't really need them, so that's the only difference really from last year. So, of course, if we're talking about digital, so you need a computer to control the radio, something to power the computer. That was running off a car laptop charger, a little DC boost converter, and hook up to the radio to the computer. And of course, being the digital modes that I'm doing are primarily FT8 and FT4, you need a good time source. So as previously, I used a USB cellular modem to get internet access for field day. So where do you start with the digital communications? Also, as I'm going, I will try and keep an eye on the comments. If you want to type in a question, I will do my best to keep peeking down at the YouTube comments. Feel free to type in questions as you may have them, and I will try and address them. So digital radio, where do you start? Well, you need a radio. You need a computer. Also, you need a way to connect them together. That's at minimum audio signals. Ideally, you'd want to push to talk also. Common ways of doing that, a lot of people like the SignalLink. It's a sort of an all-in-one solution. It supports a ton of different radios. That makes it very easy to connect up. Some radios, like my ICOM 7100, have an integrated USB connection, so you don't have to have adapters and such. There's a USB port right on the radio. Finally, homebrew. You could wire up your serial port. There's plans that use hooking up transistors to a serial port to control a push-to-talk. Use a sound card and some audio isolation transformers. One of my computers is going to sleep here, just a moment. Audio isolation transformers, that's going to be a bit outside the scope of this presentation, but I have other presentations like on the Raspberry Pi that I've discussed building your own interface. So that certainly is an option depending on what you want to do. Software, I use FLDigi and WSJTX. FLDigi can do most of the more traditional modes, RTTY, PSK, those sorts of things. And then WSJTX can do the specific modes that are more popular for contesting. FT8, FT4, it can do weak signal modes, JT65 and such. So that's what I use. I happen to run it on Linux, but they're also available for Windows and I think Mac as well, depending on your preferred flavor of operating system. So initial setup, going to be hooking up the rig control. Need to be able to trigger your push-to-talk. Some fancy ones, you can even trigger it to activate your auto-tuner automatically. Mine doesn't seem... Mine may be able to do that. I have not figured out how to make that function work. So I just hit the tune button before I go operating. And you also need the audio connection so that the computer software can hear what's coming in over the air and can transmit signals out over the air. So configuring the radio. First thing you need to be concerned about, you don't want to drive the radio too hard. You also don't want to overdrive your signal levels. If you have the computer audio too high, it will distort. It's the same thing. You may have heard some people that if they hold the microphone too close to their mouth on the repeater, it's really hard to understand them because it's distorting. Had a question, can you use the Vox on the radio rather than PTT? I think with some software you may be able to. I haven't tried it myself, but I know with certain software they do have an option where it'll make a noise to make sure it triggers. Due to all the correction, I think there's a high likelihood that the weak signal modes like WSJTX probably would work sufficiently over a Vox connection. There wouldn't really be an issue with the modes I've done at the end where it would, there's enough of a gap at the end between the end of transmitting and the beginning of receiving that you wouldn't lose anything with the carryover tail. So I think that probably could work with Vox, although I haven't personally tried it. As I was saying with the TX power, you would want to make sure that you're not running it too high. You don't want to burn out the radio, but you also don't want distortion. Filters, generally you want a very wide filter for digital because you're going to be selecting within that single sideband audio bandwidth, you're going to be selecting like sub-channels within that. And in order to see what's available to click on and lock into, you want a pretty wide filter unless you have some unusual circumstance. For example, field day, you may have to tighten it up a little because there's so much interference from close by stations. For gain, generally you want to have a medium gain set on your radio. If the gain is too low or too high, you can run into issues where it won't decode as well because either there's too much noise or not enough signal. Really, you want it right in the middle of what your receiver can lock in on. I apologize if there's any noise. The weather alarm may go off if we have more storm warnings or thunder may be coming in. So if you hear background noise, I'm sorry about that. So generally, what you have to do is get things set up, testing and tuning. So perform RF tuning for the antenna if you need to. Then connected, maybe you want to get your audio signal levels locked in correctly. I like to try and do that on a dummy load rather than on the air. So that way I'm not disrupting any operations. I can sit there and fiddle with the levels to my heart's content, get the radio tuned in really well. But it can be done on an antenna, especially if you're fairly quick about it. Also configuring the computer. That's why I was saying get your receive signal so that it's in the right range on the audio level. And then you do that usually adjusting the mic gain or the line in volume and sound control, volume control, and then configure the computer output out to the radio. There's a bunch of methods I've heard. Some people say you should look at your level control, gain, ALC level control. Just wanted to make sure there were no other questions. And for those who are joining, if you have questions, feel free to write comments. I will try and keep an eye on the comments on YouTube and answer questions as I see them. So configuring the output levels. The most reliable, simple way I've found is set the computer to 0 volume, mute basically. Activate the tune or tone test function. Most digital apps have a function that will generate a tone so you can adjust the radio. Then you monitor the radio's RF output. Ideally set the radio to 100% RF, its maximum power. Then, of course, single sideband with no audio going in, transmitting at maximum power, there's going to be no RF power going out. So then what you do is very slowly increase the volume until the desired RF output is achieved, but not too high. In my case, the ICOM 7100, it's a 100 watt radio. So I set it to 100% power, 100 watts output, and then I run I've personally found with my computers that somewhere around 10%, 8 to 10% volume gives me 40 to 60 watts output, which is quite sufficient for what I need with the signals. So next, I am hopefully going to have a live demo. I see my other computer has gone to sleep or something, so let me check on this, see if I can determine why it is gone to sleep or what it is doing. And also not mix up my keyboards too much. So also let me go over a little bit here. If I go into the full display. So this is the ICOM 7100 and the different bars here. The very first bar, of course, the frequency, and then the first bar is going to show the signal strength received. Next is the power output, how many watts output. The ALC, what it's doing. You don't want it to be off the scale clipping. On this particular radio, it does read a non-zero value anytime it's got audio coming in. But for mine, that's normal. You may want to consult the manual for your radio, along with some will specify a maximum power output that you should run for digital. I'd consult the manual for your specific radio. Next line down is the SWR. Obviously, you don't want that too high. And then the very bottom line is the current for the transmitter. So go up here. I'm going to be using WSJTX and FT8, FT4 for my examples. Maybe. Wrong keyboard. So here's the software. And I do have in the background for FT4, and FT8, having a good time synchronization is very important because it uses time slots to send the tones, and that way it knows when to expect which pieces of the signal, so it has a better chance of decoding things. Even down below the noise floor, it can sometimes decode. So in my case, I actually have a GPS receiver that's running time synchronization on my home network here. For field day, I was using the internet time source, but it works the same way. I'm using NTPD, and NTP stat is telling me it's within like 28 milliseconds. It's a very, very, very tight time. I believe for FT8, it can handle up to about a second of error. FT4, about half a second of error. Keep in mind, though, if I'm running half a second fast and you're running half a second slow, that's a second of error. If I'm running a second fast and you're running a second slow, that's 2 seconds of error. So it is relative to each other, not relative to the real universe time. So that can also affect it. It's certainly being closer to the official correct time as much as you can get is better. So you can see above me here is what's on the radio, and then beside me here is what's on the computer screen, so you can see both as I go through this. So what I'm going to do is, as I said, I'm going to come up here, bring this down to no volume. Currently, I have the radio hooked up to a dummy load, and once we get through tuning things, I'll see if the weather doesn't sound too bad. I may hook it up to an actual antenna and see if I can do a contact or at least receive some things. So I've got the sound down at 0, and I'm going to activate the tuning function. Now you see the radio has gone into transmit mode here, and down here, basically no current, no power output. That's because the volume's at 0. So we're going to go over to sound. I'm going to bring it up a little bit at a time. 1%, not really seeing anything on the radio. 2%, still not really seeing anything. Go up a couple more percent. There we're starting to register a little bit of power transmit out. And I happen to know I'm running through a couple hundred feet of not great feed line. I think it's about 300 feet of TV coax because I'm using the existing satellite TV coax that was already in the walls of this house to get out to the woods, out to my antenna. So I happen to know that I probably need to be up around 50 watts to get a usable amount of power reaching my antenna. If you have good coax or you're not running through that much, you can probably get away with a very low 5 or 10 watts on digital if you're not losing a ton of signal. So I'm going to just keep bumping it up until I see that we're right around the 50 watt mark here. And yeah, that's 11%. If I keep going up too high, now you see that the ALC line is starting to go up after the power hit 100%. You don't want that because that's going to be distorting. Your signals will not be reaching people. They will not be decodable. You know, basically, it's going to put a lot of noise on the band. No one's going to be able to decode it. You're going to wonder why you're getting no contacts. People are going to be wondering who the jerk is that's messing up their band. It's going to be splattering wider than the channel is. Lots of bad things. It's better to run a little bit less power than you want to than to run a little bit too much power. You'll have far more problems if you go a little bit too far rather than a little bit under. So now that we've dialed that in, you can, in here, it knows what frequencies are for which bands, so we can pick, it's on 20 meters. I'm going to go down here and swap my connections around, get off of the dummy load, and put on the actual antenna. And for those who wonder what it sounds like, that's what the digital signals are sounding like. Since it's running on a USB sound card, I don't actually have to have the volume up. I can turn it all the way down till I can't hear it. The computer's still hearing it. So what you see up here, as I was saying, these are these individual channels. So that this slot is someone who's making a contact. That slot is someone. The next slot is someone. There's all the way across here little sub-channels within this, what's my filter setting currently? Within this 3K bandwidth, that's all the signals. It's a very efficient mode, very low power. There we go. I like to have this in a particular view when I'm doing this. So it's very low power. I changed over to my antenna, so I want to make sure that it's tuned so that I can get on here and attempt to make a contact. So what you would want to do is pick an area in the waterfall that's not too busy. Just like anything else, you don't want to step on other people if you can help it. With all the error correction, frequently this can actually decode, FT8 and FT4 can decode people on top of each other. It's not actually that unusual in a contest to have people talking over each other and everything gets through. There isn't a specific channel per se either. You can go between these slots, you can go on a slot. It's kind of up to the person operating to decide where they need to go, just like with any other HF communication. So picked a slot in here. And this is the waterfall window that's showing all the little incoming signals. Brighter yellow and red is a strong signal. A dimmer one is a weak signal. I happen to know that my gain is best around the 10 o'clock position out here, so I'll turn it down a little bit. And that cleans up a little of the noise. And because you don't want it to be too hot, that can mess up your receiving some other signals. So down here, let me maximize this window. So over on this side, you can see here's all the signals. It's decoding everything in that 3K filter bandwidth. And it's decoding it pretty quickly. This runs on, FT4 runs on a 15-second cycle. FT8 is, I think, a 48-second cycle. I may have mixed that up, but it's pretty quick. And in this software, you go up here, the modes. You can see all the different modes that it can handle up and down here. So I'm going to go ahead. FT8 is usually pretty consistent, and the way this will work. Over here, you have the canned messages. A lot of the FT8, FT4 is contesting its canned messages. So I'll select the CQ message. You can select whether you want it on an even time slot or an odd time slot. It has to do with the taking turns. It'll automatically take turns and enable the transmitter. Now you see on this side, it's the channel I was on. And yellow is what I'm sending. Other colors are what I'm receiving. If someone comes back, it'll be a line in red. So see if anybody will come back to me. You can also, if you wanted to, instead of calling CQ, you could come over here, click on someone else's calling CQ, and it'll try and automatically populate the next messages here for the exchange and begin trying to make a contact. Sounds like some thunder picking up. May have to cut this short. I was hoping to make a contact, but we'll see. Storms are still 15 miles out. I'll give it one more try. You can see on the radio up here that when it goes into transmit, it brings it up around 50 watts. It may be with the additional coax running through the house, I may not have enough power going out right now. Or the storms might be interfering with making a successful contact with someone. So while this runs, anybody that has any questions can go ahead and type them into the chat here, and I'll be keeping an eye on it. Anyone who is coming in late, this will be available on YouTube to watch at your leisure or to share. Oh yes, a contact somebody just came in, so the computer's picked that up, and down here it's jumped to the next part of the conversation. So the sequence goes, you call CQ, somebody will reply saying what grid they're in, then there's an exchange of the signal levels and a roger, and it goes back to CQ. So hopefully it will go through, and usually it goes pretty quick when it works. And there we go. So just made a successful contact, and it popped up, and it's prompting me to log. So it picks up the information here, and I can hit OK. It's not fully, it's fairly automatic with this. However, it's not completely automatic. You notice that it has disabled the transmitter, so you can't just set it and forget it and go out to lunch or go to sleep or something. Every time you want to make a contact, you have to re-enable this transmit. I also find that a lot of times I like to go and, where's that window? And make sure after each contact, I like to go and pick a new area. Where I was, there's someone using that. I like to go and pick a new empty area each time and then go back before I make another contact. That's my personal preference. It's not mandatory, but so that's my personal preference. I hope this has given some idea of how the digital modes work and how all that is. I think I'm going to disconnect my antenna now. Hopefully, if anyone has any questions, I don't see any questions coming in on the chat at the moment, but yeah, so there's a fair bit that you can do with it. I demonstrated this with the WSJTX. Certainly, you can do the same exact things. It's pretty much exactly the same procedure if you're doing PSK, if you're doing RIDI, if you're doing any of the other modes. Setting up the radio correctly and getting the levels correct from the computer to the radio and radio to the computer, it works exactly the same way regardless of what HF digital modes you're using. The one exception is if you're doing something like APRS, where it's on FM. Obviously, FM, it's going to be sending out a signal the full power of the radio, whether you're putting in no audio or maximum audio modulation. So that's a little bit different to tune what the correct levels are. And I usually use trial and error for that. But for sideband, this is the most reliable way I've found to make sure that your audio being transmitted is as clean as possible. And I hope that gave a brief overview to better understand some of the new modes that are coming out and popular with contesting. WSJTX with the FT4 and FT8 digital modes. Those really worked well on field day, being able to crank through a large number of contacts and also maximize the bandwidth, fitting as many different QSOs in the amount of spectrum as possible very efficiently, and being able to get the really weak ones as well as the stronger ones without stepping on each other too badly. I felt it was very successful. Let's see. And I don't see any other questions. So yeah, I hope everybody enjoyed it, and I think I'm going to wrap this up before the storms knock out power again. Hopefully that won't happen this time. Thank you everyone for watching, and also you can share this link, the YouTube link, with anyone else who may be interested in it, couldn't watch it. It should remain available on YouTube for anyone to watch or rewatch at their leisure. And have a good evening.